Hi friends, Ms. Gove here. What we're going to work on today is a little video about how to take a periodic table square and what we know about that information in the square and convert that information into a model drawing, which gives us a little bit more of insight into what that atom actually visually kind of looks like, what's going on visually. So let's get started. All right, so here we see a periodic table square, and this is element number 10, that is neon. We see its symbol right here, that's neon, right? We see the 10 and the 20, and we remember that this is the smaller of the two values, the lower or lesser of the two values, and that therefore is our atomic number, okay? So we need to make sure we memorize that's going to be our atomic number. So I'm just make a little note to myself here that this is the number, okay? Number sign, right? And then this guy is my mass. So I'm going to make a little M next to him just to help me remember, in case I'm not quite sure how to remember. Now, we need to figure out first and foremost, we'll start with step one, okay? And step one is pretty simple, all right? This is something we've been working on, and there's other videos that can help you with it if you're stuck. But step one is to figure out how many protons, electrons, and neutrons are in one atom of neon. And we do this by using a couple different things. There's a couple different tools. But one of the ones that we learned that is really helpful is if we think back to Ape Man, okay? A, P, E, and M, A, N. And you have to remember that between M and A is that minus sign so that we make sure we do the subtraction we need to do. So this will help us in our process of finding the number of protons, the number of electrons, and the number of neutrons in a given atom. The number of protons is equal to the atomic number. That's what A signifies. So in this case, our atomic number is 10. That leaves us with 10 protons. Okay? You'll see down here my reminder that the number of electrons is also equal to the number of protons, or the atomic number. And so we also are going to have 10 electrons. Finally, the neutrons are a little bit trickier. Okay? That's where we're going to have to do a little bit of a subtraction problem. But you see our mass is 20. That's our mass, minus the atomic number, which is 10. So 20 minus 10 is going to result in the fact that we also have 10 neutrons. So step number one, find the number of each of the subatomic particles, how many protons, how many electrons, and how many neutrons. Then we'll move over here to step two. Step two is doing the actual drawings themselves, okay? So for that, we're going to first start with the center of the atom. The center of the atom is what we call the nucleus, right? So for the nucleus, we're going to go ahead and put the particles that belong inside that nucleus. And there are two particles, if we remember correctly, that belong in the nucleus. Those are our protons, and in this case for neon, we have 10 of them. So we're going to put our 10 protons in the nucleus, and we also remember that neutrons are in the nucleus, so we're going to put our 10 neutrons in there as well. And you can omit the 0. You'll see it both ways, N with the little 0 or just N, all right? So now our nucleus is all set. That's the center of our atom. That's where all of our mass comes from. And we've accounted for all of our mass, which are our protons and our neutrons. So check, all right? And even if you wanted to, you could run a little line through these to let yourself know that I did this, okay? Now I need to worry about my electrons. And there's two different models that we can do to tell us about our electrons. Okay, the first one is what we call a cloud model. And I will tell you, this is probably one of the easier of the two. This cloud model, oops, sorry about that. This cloud model makes one big circle around the outside. And then all it asks you to do is to put the electrons in there. Ta-da, we're done. Okay, not the greatest, not the most helpful visual, because we kind of need to know a little bit more about what's going on with those electrons. And what we really are after, ultimately, is figuring out how many electrons are on the outermost shell, or the most accessible electrons to us, because those electrons are really important in determining reactivity and the likelihood that it's going to bond. So let's look at that real quick, okay? So I'm going to undo these, take these away, and let's look at the Bohr model, okay? In a Bohr model, we have multiple rings, and it shows energy levels, if you will. That's what we call them, or you also can call them electron shells. And what it does is it gives it multiple places that the electrons may be, and the likelihood that they may occupy those spaces. So closest to our nucleus, we actually will end up with 2 electrons in our nucleus, okay? 2 electrons in the nucleus. And those electrons are represented by these tiny little circles. Okay? And we're going to put 2 dots. Yes, they should be dark. Perfect. Okay? The first electron shell can only hold 2 electrons. That's it. That's all it can hold. It maxes out at 2. Okay? So we have to remember that the first one maxes out at 2. Now, let's go on to the next one. Oops. Okay, so we're going to make, goodness, sorry. We're going to make another shell now. All right, how many more electrons do we have? Well, we've already placed 2, right? So we need to place the rest of the 8 to get all 10. And in order to do that, we're going to add those to our circle here. And this second shell actually holds up to a maximum of 10. So we can go ahead and add 8 more on this shell. There, my friends, is a model of a neon atom. It shows the protons in the center, the neutrons in the center. It shows 2 electrons maxing out the inner, and then we put the remaining 8 on the outside. Let's try this again, but a little bit faster this time. We'll do potassium. We know that the atomic number is equal to the protons, so there's 19. We know that if we have 19 protons, we must also have 19 electrons to balance and keep it neutral. And then remember, we do math for the neutrons. So 39 minus 19 is 20. Again, we're going to start with our innermost circle. That is our nucleus. For that nucleus, we're going to add our protons, 19 of them, and our neutrons, 20 of them. Then, from there, we're going to add another circle. This is the first energy level. Do you remember how many electrons are on that first energy level? 2, okay? So there's 1 electron, 2 electrons. But now I still have to account for the next 17. So let's make ourselves another energy shell. The next energy shell, we said, maxes out at 8. So let's go ahead and add in those 8. 1, 2, 3, 4, 5, 6, 7, 8. Oops, sorry. Just give me 1 second. It's a little trickier in here than I would like it to be. All right, there's 8. Okay, now we have 10. We still have 9 more. So what can we do? We need to add another shell. And that shell will also end up with 8. Okay, so let's put 8 more on this shell. Now you can see how it's a lot easier when you're hand drawing it than using the computer, but it still is possible in a variety of ways to make these atoms. Now, am I finished? Not quite. All right, that's 2 and 8, which is 10, and 8, which is 19. So I need one final shell for that final electron. And there we go. Oops. And then I'm going to drag that final electron right there on that outer shell. And this would be an example of one atom of potassium.